Okay. Now again, listen, super duper easy. Today we have area of a parallelogram and area of a triangle. Obviously, the area of the parallelogram is simply base times height. And believe it or not, a triangle is just half of a what? Parallelogram. All right. So the area of a triangle is just 1/2 base times height. All right. Now, obviously, the problem comes when you don't have a base or you don't have a height and you have to use trig or you have to use the 30, 60, 90 rules, all right, to try to calculate what that is. All right. So I'll do a couple problems with you. And then, honestly, I'm just going to let you go because you can see it really is just finding area of these shapes. Very simple. All right. So here we go. Let's start with question number 1. All right, what is considered the base here? 18. That's right. And what's considered the height? 6. Exactly. So you just write down area equals base times height. Area equals 18 times 16. And that's it. So all you have to do is tell me what 18 times 16 is. 280. All right, so we will write 288. You measure area with what? You measure area with squares. All right, you measure area with squares. So now number 2. Number 2 is called a rhombus. All right, all sides are equal. All right, a rhombus is a rhombus a parallelogram. Yes, therefore the same formula applies. Its area equals base times height. Now we want the exact height, or I know it says round to the nearest tenth if necessary, but again, we want to practice our rules with the 30, 60, 90 triangle. All right. So if this is 60 degrees, all right, if we were to, or not, the angle is 60. So what I need you to understand is over here, this side is 24. Do we agree? All right, and then you can see it better from this triangle over here. This is 60. So opposite 30 was what? Half the hypotenuse. Thank you very much. So that's going to be 12. And in this case, the height would be what? That's correct. 12 radical 3. All right. So area equals the base, which is what? 24, and the height is 12 radical 3. So area equals 288, I believe, radical 3 inches squared. All right. That's not that hard. 12 times 12 times 2. All right. So if we do 288 radical 3, let's say on the test, you don't remember the 30, 60, 90. I'm okay with you writing and using trig to solve that. All right. So in this case, we would say I'm missing the height, correct? And I have the hypotenuse, correct? So that would be what? Sine of 60 is equal to what? X over 24. X over 24. All right. So now everybody take your calculator and go X equals 24 sine 60. Right. Oh my gosh. And then once you got that answer, right, that represents the height. So now do 24 times that answer. And then do 288 radical 3, and they should be the same thing. If they're not the same thing, then you didn't do it correct on your calculator. Negative 20. I got a negative. Listen one more time. Come on. All right. Hey. All right. You're just plugging the numbers into calculators. You can't ask me how to plug these in on the calculators. All right. You just can't.
It's like 20.
24 sine 60. All right. That shouldn't be negative.
Try to do 24, then sine, and then 60 in the parentheses. I get -7. I'm clicking sine.
Yeah, are you doing 24 sine 60?
4 sine 60.
Well, you for all this time, I don't know why your mode is in radians.
I don't know what that means.
All right.
What did that change?
The answer. Right. Yeah, it's always your mode has always been in degrees. For those of you guys who have your mode in radians, you haven't that maybe that's why you made all the mistakes on the last trig test. All right. Every single time your mode should be in degrees. All right. When you get to high school in pre-calc, they'll tell you about the radians. But right now, all it is your mode should always be in degrees because we're talking about the degrees of a triangle. All right. Number 3, area is just what? 1.6 squared, correct? Which you should come up with and say 2.56 centimeters squared. All right, anybody have any questions with that? All right, now let's come over here. All right, they're trying to, you know, I mean, it's just really that simple.
Is 20 the whole line?
20 is the whole thing. All right. So this one is just what?
160 inches squared.
That's how easy. All right. Nothing. All right, here we go. Now, once again, we are missing the height here. All right, so opposite angles are congruent in a parallelogram, so we know this is a 45, 45, 90. Again, we are reviewing, all right, making sure you are ready if you're taking a test, all right, to get into the high school of your choice. All right, you need to know this. All right. So to get to the leg, what do we do?
Radical 2.
Divide by that.
That's right. We're getting smaller, so we divide by radical 2. So this would be 15 radical 2. And if we simplify it or we rationalize it, it would be considered 15 radical 2 over what?
2.
Over 2. All right. So now our area is simply 15 radical 2 over 2 times 30. And I think that's 225 radical 2 square feet. Anybody have any questions with that? Of course, let's just say we forgot, even though that's not possible. All right, let's say you forget. All right, and we're interested in the height. What trig function are we going to use to calculate the height? Well, either one, it doesn't really matter. If you put the 45 down here, you could use the cosine, right? Now, again, you can't really use tangent because the 15 is the hypotenuse. All right, so you have to use the one with the hypotenuse. So in this case, you could say the sine of 45 is equal to h over 15. And so h is equal to 15 sine 45. Anybody have any questions with that? And now take the 15 sine 45 answer, all right, and multiply that by 30, and that should be the same as 225 radical 2. Anybody have any issues?
How did you know it was sine?
Here's the 45, opposite and hypotenuse. Yes. Look, now I'm part of the reason why I'm trying to encourage you to use your calculator as much as possible is because on all the standardized tests now they're letting you use your calculator. All right, so the more you know how to use your calculator, the better your score can be. All right, but you have to use it. All right, and some of you guys, I'm not sure if you're understanding what I'm saying. You should be able to check what 225 radical 2 is. All right, if that's the same as what you got from using the trig. All right, now let's try to find, okay. Now, we have to be careful because here it wants to find, guess what else I didn't do? I just noticed the directions. We're technically supposed to calculate the perimeter. All right, so I need to go back. I want to go back and calculate the perimeter. All right, so number one. All right, now, again, please look up for finding the perimeter. Right, in order to find the perimeter, I need this side. Please, we're doing the Pythagorean theorem, correct? Right, do we agree that's 8 times 1 and 8 times 2? Come on now. Everybody in here should be able to tell me that that's 8 radical 5.
Obviously.
Come on, don't say that. We've done it a bunch of times. A squared plus B squared equals C squared. The 8 is a common factor. Therefore, 8 must be a common factor in the hypotenuse. And then some of you are asking me, how did I get 5? Are you having trouble with 1 squared plus 2 squared? Right? That's it. That's all it was. Now, if that's over your head, just do 8 squared plus 16 squared and break it down. What? It's A squared plus B squared equals C squared. We've been doing that for a long time. A squared, 1 squared, plus 2 squared equals C squared. 1 plus 4 equals C squared. 5 equals C squared. C equals square root of 5. Correct? So now one side is 8 radical 5. The other is 8 radical 5. And this side is 18. So our perimeter is going to be 36 plus 16 radical 5. Now, again, I think that's important. Part of the reason why I wanted you to do the perimeter was because I want you to remember how to add radicals, all right, and how to break down radicals. All right, that's a big part of your test coming up for some of you guys. Anybody have any questions with that perimeter?
It's radical 5.
Why do you want it to be radical 10?
There's 2 of them.
No. Remember, you're adding 8 radical 5 plus 8 radical 5. Now remember, the number in front tells you how many radical 5s you have. Do you hear me? There are 8 radical 5s. You add another 8, you get 16. All right, number 2, the perimeter is kind of easy. The perimeter is just 4 times 24. Does everybody agree with that? So that's 96 inches. Notice I didn't say inches squared. I said inches. All right, just like number 3, the perimeter here is 6.4 centimeters. Everybody good with that? Number 4, the perimeter is, what's the perimeter? 60 inches. Easy, I agree. And then number 5, the perimeter is just 90 feet. All right. So finding the perimeter and area. I'm trying to find something that's more challenging. All right. So please now, the area of the triangle. All right. The area of the triangle is 1/2 base times height. All right. Now, if I'm going to calculate All right, the area of this triangle. Right, I need to find the base and the heights. All right, and I always used to tell kids the base and height are connected by the right angle symbol. All right, so if I'm doing area first, area equals 1/2 base times height. So what's the base and what's the height?
The base is 18.
Nope, definitely not 18. Now you're making a good mistake, whoever said 18. All right, this right here is just an extension. All right, that's not part of the shaded region. You with me on this? All right. Now, what's the height going to be? 4. 4. All right, the height is definitely 4. So half of 15 times 4 today is 30. Do we agree? Centimeters squared. Anybody have any questions with that? All right, now the perimeter. The perimeter so far is 19, correct? Because we know 15 and we know 4. Does everybody agree with me? All right, now come on, guys. The hypotenuse, square root of what? 225 plus 16, which in fact is 241. Come on, that's not that hard. Now, if you don't know, come on, speak up. I don't mind. All right. Does the square root of 241 simplify? No. Plus the square root of 241, and that would be centimeters. Yes, ma'am. I just can look at the number 241 and know that there's no perfect squares. Now, if you can't, right, what I'm suggesting is this: 4, 9, 16, 25, 36. I just scrolled through these numbers real quick. You with me? 121, 144, and so on and so forth, right? However, watch how easy it was. It's not even, correct? 141 is not even. So none of the evens will go in, right? So I was clearly able to wipe those out. Do you agree with me on that? Right. And then I said, well, if I add 2, 4, and 1, that's 7. So nothing with a 3 will go into it. Does that make sense? It's not divisible by 25 because it doesn't end in a 5. And then for me, it was just a matter of, does 7 go into 241? Right. And I need 49 to go into it. Does that make sense? So I just knew it wasn't that. And 3 goes into 81. So I knew it couldn't be 81. And then 121 is 11 times 11. 11 doesn't go into 2. You see what I'm saying, right? It's really easy to know that it doesn't break down. All right. But most of the time, if you can say it's not even and it's not divisible by 3, that eliminates a whole bunch of perfect squares. Do you see what I'm saying? So then it's kind of easy to know it doesn't break down. All right. Now there's some strange perfect squares, but again, that's 241 is not one of them. All right. Good question. All right. We're going to practice over here real quick. Come on now. I want to know what this side length is right here. 8 radical.
8 times 1 and 8 times 2.
You're right. Come on. 8 radical 5, right? Because this is 8 times 2. This is 8 times 1. So this is going to have to be 8 times the square root of 5. You with me? So now what's the perimeter of this thing?
56 plus 8 radical 5. Good job.
56 plus 8 radical 5 feet. And now we can say, again, be careful, area is 1/2. What's the base? 22. And what's the height?
16.
16. All right. Now remember, the reason why occasionally The height has to be drawn on the outside because the height is always the perpendicular distance to the base. Now, everybody look up on the board real quick because I'm trying to show you something. Does everybody agree there is no perpendicular on the inside, correct? So what did they do? They had to extend it out. That's why sometimes you'll see dotted lines. They had to extend it out in order to find that it's perpendicular. This 8, come on now, listen to what I'm saying. This 8 has nothing to do with the base. Nothing. All right. So what's 1/2 of 22 times 16? I think that is 176 square feet. Yes.
So the extension of the base doesn't matter, but the extension of the height matters.
That is exactly correct. Very smart. This 16 is the height, right? It's not that the extension didn't matter. It's that the only thing we were interested in was the height.
Do we ever need the extension of the base?
I don't think so. In order to calculate the third side, maybe. That's why I think they did it. You with me? All right. So I don't think any of those are tricky. I think we did problems like 13, 14, 15. Does everybody remember the triple for 15? Oh, no, that's not going to work. That one's really silly. All right, 16. Um, Here, this is 4 times what? 4 times 3. This is what? 4 times 5. So this is going to have to be 4 times radical.
It's not 4 times 4.
No, because remember, that's the hypotenuse. They tricked us on this one. Right? 3 squared is 9. 5 squared is 25. 25 plus 9 is what? There you go, 34. All right, so just be careful. It looks like it should have been a 3, 4, 5. All right. Check that. The height of a parallel. Okay. Now we'll get into some algebra just to make sure. All right, you're in good shape. Everybody look at 19. The height of a parallelogram is 5 more than its base. If the area of the parallelogram is 204 square feet, find its base and height. All right, so let's just draw a parallelogram and label it. All right, so the height of a parallelogram is 5 more than the base. All right, so this isn't very good. So again, if this is the base, then the height is what? What plus 5? Yeah, you could use x, but that's b plus 5. Is everybody good with that? Now, the area of a parallelogram is 204, right? So that means base times height is equal to 204. Everybody agree with that? Now we distribute b squared plus 5b equals 204. Does everybody agree with that? And now, because it's quadratic, we set it equal to 0. B squared plus 5b minus 204 equals 0. Does everybody agree with that? Right? Now I've got to factor this. All right. I hope it does factor. B and B. What do we got for 204?
12 and 17.
Anybody else say 12 and 17?
17.
Is she correct?
Yes.
Surprised.
I got lucky.
12 and 17. And now the 12 is what? And the 17 is? So when we solve this now, we set it equal to 0. B minus 12 equals 0. B plus 17 equals 0. So B is equal to what? And B is equal to what? Can the base be negative? No. All right, so the base is equal to what? Base equals 12 feet, and the height is equal to what?
17.
17 feet. Is everybody with me on that? All right, now I want to show you something that's kind of cool on your calculator. The calculator has the ability to solve quadratics fairly easy. All right. So I would like everybody to go to apps. Apps. All right. Apps. Does everybody see that?
Easy.
I only have one app. Yeah, I have one.
Oh,
I have finance. Same.
okay. Some of you guys, for some reason, this app, for some reason, your calculator got cleared. All right. There's a way to transfer the data over. So I will try to work on that for you from one calculator to another. But for now, it's not on there. So if you don't have it on there, you can share with someone else. But does everybody see apps? If you don't, it's under number 9. And I think it's called like poly simultaneous or something like that. Poly, your eyes, everybody see number 9? Hit that for me. All right, watch how cool this is.
Access instrument.
All right. Now on this, the first one is a root finder, which is what we're doing. I don't know why they call it roots. And the second one, believe it or not, is systems of equations. So your calculator has the ability to solve all of the systems of equations. I just never showed you that. And it has the ability to solve all the quadratics. So what I'd like everybody to do is hit number 1, hit enter. Now, this is a quadratic, correct? So that means it's second order. If I wouldn't have called it order, I would have called it degree, but it is a second degree. Do we agree? Everybody with me on that? All right, now once you put it on the second degree, then on here now, you want to do the next. All right, now your next is the graph button. So hit the graph button. And now you put in the coefficients and then it'll solve it for you.
Whoa. What's the coefficient?
Stop with that. The coefficients, yes. What is the A? The number in front of the x squared term. So in our case, A is what? 1. Our B was what? 5. And our C was what? -204. So if you do -204, then you hit solve button, which is the graph. It solved it for you. Isn't that really cool? Last year it made a whole difference.
I've gotten A plus last year.
What happened?
It's just
So you do apps and then you do.
I didn't know what it
One.
Oh, is that?
Then it was.
Oh, yeah, and then you. What? Why don't we just do this? I would've got an A plus last year.
Did everybody see how to use that? You see that?
Yeah,
Okay. Now, for you guys, next year, hey, listen, for you guys, when you head off to college, when you head off to high school, all right, you really need to get you one of these, all right? One of these, not one of those, all right? I like these better in many respects because you don't have to worry about charging them, but this has all the latest, greatest technology and applications on them. For those of you guys who don't have that on your calculator, I will try to get it on your calculator. All right, I just have to learn I have to remind myself how to share the data back and forth. All right, so that being said, I would like everyone now to kind of flip through here and do your best to answer all 26 questions. All right, get busy on that.